All right, this is going to be the video guide for both the molarity and the dilution worksheet. I think you have 6 problems of each, so just to kind of show you how this works. Just so you're aware, on the molarity, every single one of these problems will involve this formula. So you have molarity equals moles of solute per liter of solution. You must have moles, you must have liters. Okay, and then all it is plugging in what you know, rearranging, solving for the one unknown. So this first one, it said you have 2.3 moles, so you know the moles, put that on top. And then it says you have 0.45 liters of solution, so that was already in the units you needed, liters. So all you do is simply divide, and when you do that, with sig figs, 5.1 molar, pretty straightforward. Second one, what's the molarity of a solution? 1.2 moles dissolved in 1.22 liters. Once again, this one is straightforward because you know moles, 1.2 moles divided by the liters, which is 1.22 liters. You simply divide with sig figs, 0.98 molar. Okay, for number 3, as to the molarity of solution, this time we have grams. So the first thing you have to do is change those grams into moles. We're going to start out with what we know. 35 grams of sodium chloride. You know how to do grams and moles. You've done this for a long time. Every mole of sodium chloride weighs 58.44 grams. Grams cancel, divide, and that tells me you have 0.599 moles of sodium chloride. And then it says you have 1 liter. Okay, when you divide this, it's going to round to 2 sig figs because of the 1.0. It's going to be 0.60 molar is the molarity. Okay, 3, what is the molarity of solution? And so once again, we have grams again. So we're going to start out with 10 grams of silver nitrate. We need to make those moles. And so we need molar mass. Every mole of silver nitrate weighs 169.88 grams. That's just you adding up the masses of all those elements. When you divide, you find out that that is 0.0589 moles. Notice this time it gave you milliliters. You cannot do milliliters. It has to be liters. If you convert milliliters to liters, you simply move the decimal 3 places to the left. So this is going to be 0.5000 liters. You need that for the sig figs. When you divide this, notice you're going to be limited to 3 because of that number. 0.0118 molar is the answer. Okay, last 2. How many grams of potassium nitrate would you prepare for a 2 liter of a 0.5 molar solution? So this time we know you have 0.500 molar. Okay, and oops, we know that the 2 liters, we know that. We don't know the moles. So to solve this, you're going to cross multiply. Well, 2 times 0.5 is going to give you 1 mole. Is the amount that we have, and so we're looking for grams. This is simply going to be molar mass. Every mole of potassium nitrate weighs 101.11 grams. Okay, we're limited to, it looks like 3 sig figs, so it's going to be 101 grams KNO3. Last one for the molarity, what volume? So this time we have the molarity, we have a mass. So let's see, let's change that mass. Let's change the 5 grams of potassium chloride. Let's change that to moles. So I know every mole of potassium chloride weighs 74.55 grams. Grams cancel. I divide. This tells me that I have 0.067 moles of potassium chloride. We don't know the volume in this instance. We do know that it is 0.25 molar. So to solve for x, we basically cross multiply. So these two things are going to switch positions. Okay, and so what we're going to do, this is going to end up, when you multiply that and then divide, you're going to end up with 0.27, and you have to realize that this is going to be liters. If you wanted to do it as milliliters, you could, but there's no need. You could say 270 mils. Either one is acceptable. So that is the molarity portion. Now we're going to go over and answer the dilution questions. Okay, so let's take a look here. Dilutions. All right, and let's see. It says how much concentrated 18 molar sulfuric acid is needed to prepare 250 mils of a 6 molar solution. The key is, guys, you don't have to use liters in this case. With molarity, you have to, but dilutions, you do not. So there is the formula we're going to use for every one of these problems. M1V1 equals M2V2, meaning the initial molarity times the initial volume is equal to the final molarity times the final volume. You're going to know 3 of those 4 things, plug them in, rearrange, solve for the unknown. Okay, so let's say I want to put the 18 molar here, and we don't know the volume of it, but we know that we have 6 molar and 250 mils. All you have to do is divide by 18 molar. The molar cancels. 6 times 250 divided by 18, 83 mils with sig figs. How much concentrated 12 molar hydrochloric acid is needed to prepare 100 mils of a 2 molar solution? So once again, 12. Yeah, my pen's screwing up here. It's wanting to take the day off. 12 molar, right? And let's see, we don't know the volume that goes with the 12 molar. We do know that we have 2 molar, and the volume of that is 100. And this is being real finicky. It's just being real laggy. We said 100 mils. I'm going to take my time here. Okay, all you have to do is get X by itself. You're going to divide by 12 molar. Molar cancels. 2 times 100 divided by 12. When you do that, 17 mils is what it's asking for. For the third one, let's see, it says, to what volume should 25 mils of a 15 molar nitric acid solution be diluted to make it 3 molar? Well, once again, molarity, we have 15 molar. The volume that goes with that is 25 mils. Okay, we know 3 molar, and we do not know its concentration. Get X by itself. We're going to divide by 3 molar. Molar cancels. 15 times 25 divided by 3. When you do so, that's going to be with sig figs 130 milliliters. Number 4 says if I dilute 250 mils of 0.1 molar lithium acetate into a volume of 75 mils, what's the concentration? So in this one, I know that the 0.10 molar goes with the 250 mils. Okay, I want to know what the concentration is if the final volume is 750 mils. So once again, what we're doing is rearranging and solving for X. The 750 mils goes down here. Mils cancel. 0.1 times 250 divided by 750. When you do so, that final concentration is going to be 0.033 molar. Okay, last 2. If I have 340 mils of a 0.5 molar solution, what is the concentration if I add 560 to it? So you need to be very careful. We're not going to use the number 560 here, because if you look at it, okay, the initial concentration is 0.50 molar. The initial volume is 340. And then, so we're not going to put 560 there because it says I add 560 to it. That means that the final volume is 560 plus 340, which is 900. Okay, so I'm going to rearrange and solve. I'm going to put the 900 down here. Mils cancel. 0.5 times 340 divided by 900. When you do so, you're going to find out that X is 0.19 molar. 2 sig figs. And then the last one. It says if I leave 750 mils of a 0.5 molar sodium chloride solution uncovered and 150 mils evaporates. Once again, you got to read. Okay, so it doesn't say it evaporates down to 150. It says 150 evaporate. Initial concentration is 0.50 molar. The initial volume 750 mils. Okay, if 150 evaporate, that means that you have 600 left. So that number was not in the problem, but you can solve for it. You have to read carefully. Solve for X. 600 mils, divide by that. Mils go away. 0.5 times 750 divided by 600. The molarity, 0.63 molar. That's a 3.